Hi everyone, this is going to be a quick video about solving quadratic equations by completing the square. There's a lot of ways we can solve quadratic equations. Not all of them always work, but completing the square will always work to find real and non-real solutions. Even if it's not factorable, we're going to make it factorable. So check this out. Okay, so the first thing to remember is this type of problem right here. This is a problem that we really like to see. This is just something squared equals 25. A lot of you guys could probably do this in your head right now. We have something here in the parentheses that's squared is 25. Well, that's got to be 5 squared is 25. Also remember negative 5 squared is also 25. So let's just do this problem real quick. Since it's just something squared by itself, we can take the square root of both sides. Remember when we do the square root of a number, we have to find both square roots of that number. So the square root of x plus 3 squared is just x plus 3. And that equals 5. But we have to write another equation here. X plus 3 could also equal negative 5, right? Because there's two square roots of 25, regular 5 and negative 5. And then we just solve both of these. So we get x equals 2, and we get, subtract 3 from both sides here, and we get x equals negative 8. So those are our two solutions to that quadratic equation. Pretty quick, pretty easy to do. Our goal today is we want to make equations look like this because then they are easy to solve. So I'm just going to erase this real quick. I just want to show you what this looks like. So we have x plus 3 squared equals 25. So if we drag this out with algebra tiles, that would look like this, right? X plus 3 squared. We have literally a square that is x plus 3 long, right? On the top, it has a width of x plus 1, 2, 3, and a sort of height of x plus 1, 2, 3. So essentially what this says right here is x squared plus 1, 2, 3, 4, 5, 6x plus 9 equals 25. Now, which one of these is easier to solve? This one is much easier to solve because we can just take the square root of both sides. Here, this would take a lot of work. We might have to factor it. We might have to make it equal 0. But what we want to do is we want to make this second equation into this first equation so that we can solve it very easily. So that process is called completing the square. All right, so when you're completing the square, you're literally trying to make something a perfect square. Even if it's not a perfect square, you're going to make it be a perfect square. What do I mean by a perfect square? I mean literally in space, it is a square. So we have x squared. We'll do this with algebra tiles first. So we have x squared. I don't know what that is. We have x squared plus 6x. Okay, well, if this has to make a square, let's just drag out my 6x's. If this has to make a square, then 3 of them have to go here, and 3 of them have to go here. Just kind of following the standards that we've already thought about. So we've got x squared. Here's x squared plus 6x. Plus what is going to make this a square? We need to complete this square. And what's going to complete that square? I don't think I need to drag out the yellow tiles, but they're going to go in here. And I think you guys can see that there are going to be 9 of them. There needs to be 9 right there. That spot is going to be filled with the number 9. 9 ones. That is a perfect square What's so good about having a perfect square? Well, you can, number one, you can factor it super easily. You can see the length and the width of it. The length of this is x plus 3. The width of it is x plus 3. So it is just x plus 3 times x plus 3, or a better way of writing that is x plus 3 squared. So keep that in mind as we're going through some problems. We're going to use that to solve some problems in a pretty cool way. Okay, so here's a big fat quadratic equation that we got to solve. And I don't know if this is factorable on the left side or if it's not. We could make it equal 0, and then we could try to factor it. It might not even be factorable, though. Here's one way we're going to do it, and that's going to be by completing the square. And when I do completing the square, I like to literally think of it as a square. So I'm going to draw this first part out here. We've got an x squared. So I've got an x squared. Looks like that. And then I've got 8 x's. Well, if I want it to be a square, then I need those 8 x's to be split up in half. I need 4 of them to be over here, and I need 4 of them to be over here on the bottom. Okay? And now I need the number 15. Let's not worry about what they're telling us it is. Let's think about what it actually is. So what is this actually down here? What actually completes this square? What fits there? Well, I think you guys can see if we filled it up, it would be 16. So we need 16. So let's look back at our problem here. So this thing needs to be 16, but it's not. So what can we do? Well, what we can do is we just make it equal 16. How do we make it equal 16? We just add 1 in this case. We can't just add 1 to one side, though. We have to add 1 to both sides. So let's see what we get here. We get x squared plus 8x plus, whoops, forgot my x, plus 16 equals, looks like it's going to be 9. Okay, this is good. Because this this expression, this equation, is just, we can factor this left side very easily. This is just x plus 4 squared. Look at, we already factored it. It's x long there, and it's 4 long here. This is x tall here, and it's 4 long here. And that equals 9. Now this problem now is a problem that we've done a bunch of times. This is just something squared equals some number. We can just take the square root of both sides now. So we have already completed the square. We've done all the new stuff now. Let's just finish solving this problem. So I might need some more space here. We get x plus 4 equals plus or minus 3. Right? Because the square root of 9 is both 3 and negative 3. So I'm going to draw some arrows here. I get x plus 4 equals 3, and I get x plus 4 equals negative 3. So what does that give us? We get, let's solve that. Minus 4 from both sides, we get x equals negative 1. And if we subtract 4 from both sides, we get x equals negative 7. Boom. There's our two answers. We took something that wasn't necessarily factorable, and we just made it factorable. So let's try another example. All right. So these numbers seem pretty big, so that could be kind of scary. But remember, always our zeroth step. Our zeroth step is always to factor out the GCF if there is one. It looks like these numbers are all divisible by 2. So I'm going to divide them all by 2. And I think that'll make things a little bit easier. Divide everything by 2 on both sides. So that gives us x squared plus 10x plus 8. Whoops, not 8. What am I thinking? Plus 32 equals, what is this here? This is 43. Okay, so that's where we are. Okay, let's see what needs to happen now. So we want to start drawing our square. We want to make this left side into a perfect square. Let's see how close it is. Well, we've got x squared right there, and then we've got 10 x's. So if it's 10 x's and it's got to be a perfect square, that means that 5 have to be on each side because it's got to have the same length and width. So let's add another one there. Okay, 5. And then 5 on the bottom. Okay, that'll be 5. And then, so that's in red. And now we need to complete the square. So what is going to fit down here? Well, we've got 5 here and we've got 5 there. So this is going to have to be 25. So we need this thing right here. We need that term to be 25, but it's not. So what do? We just make it be 25. So how do we make this be 25? Well, we subtract 7 from it. So we're going to subtract 7 from both sides. You can't just change it however you want. You have to do it to both sides. So then we get x squared plus 10x plus 25 equals, let's see here, this is 36. So this side here on the right-hand side, we're not really doing anything on purpose to this side. This side is just kind of a victim. It's just whatever happens to it, happens to it. We are just trying to figure out what this side is. Okay, so now we've got this side all lined up. This is a perfect square, trinomial. So we're going to go ahead and factor this, and we already do the picture, so we can factor it really easily. This is just x plus 5 squared. We made it that way on purpose. It's a perfect square. It's x and 5 long, and it's x and 5 tall. And then this side is still 36. Okay, this should look really nice because now on this side, we just have something squared. We can just take the square root of both sides. So I'm going to take the square root on this side. I'm going to take the square root of this side. So we get x plus 5 equals, square root of 36 is 6 and negative 6. So I get plus or minus 6. So now we just got to finish this problem out. We get x plus 5 equals 6. And we get x plus 5 equals negative 6. So we'll just finish solving. Subtract 5 from both sides. And we get x equals 1. And we'll subtract 5 from both sides. And we get x equals negative 11. There we go. Let's make sure we did this right. We can plug this in really easily. So let's just plug in this 1 and just see if that's right. So 1 squared is 1 times 2 gives us 2. 20 times 1 is 20. 64 is just 64. 2 plus 20 is 22. Plus 64 is 86. So that one's right. And we could check this other one as well, but I don't want to make this video any longer. Make sure you're working on your homework. Make sure you're checking your answers online on Google Classroom, and I'll see you tomorrow.